Okay, so I'm gonna explain to you guys lesson 9b in the book by Morin over here. This book, Morin, Tenenbaum, and Harry Pollard, Ordinary Differential Equations, lesson 9b. And basically, it's just a proof or the solution, rigorous solution, basically, to the exact differential equation, which is p of x y dx plus q of x y dy equals to 0 under the condition that the partial of p respect to y is equals to partial of q with respect to x. What this means also is that basically this condition here, or this identity here, proves or says that there exists a function f of xy such that the partial of that function with respect to x is equals to this function p, and the partial of f with respect to y is equals to q, and this is usually called a potential function. So we use this relation, we focus on this, and we say that f is equals to the integral from x0 to x, which is a constant lying in the region or the domain of both p and q, and x is just an independent variable plus an arbitrary constant of integration. Now you can basically prove that, or make sure that these two are complement each other, because if you take the partial with respect to x, then you find that the integrand of this, or the value of this integral, which you can say the integral of p of x y dx, if we set that equals to a function, let's say g of x y, right? In this case, y is treated as a constant, so you can say that this is just x, and if you place a specific value, x is equals to x0, you find that this thing, which is g of x0 itself, is a constant. So if you integrate that, it will be subtracted, so that you'll have g of x minus g of x0 plus r of y. So if you take this thing and differentiate it with respect to x, this is a constant, so it goes to 0, and this is a constant because you treat y is equals to a constant. So you find out that it's simply just going to be g prime of x, and we know that g, in this case, prime of x will just be equals to p, because you take the derivative of an integral, which results in the integrand. But also we use a relation here that the partial of f with respect to y is equals to q, so we basically substitute in this relation that we found here into the other relation that we have, and we find out that the partial of y of this integral plus r prime of y is equals to q of x, and you have a property that says that if you have a function of two variables and you're integrating to one variable, and then outside that integral you're differentiating that integral with respect to the other variable, so in this case it's y, so you can enter that integral, or that you can enter the differentiation, or the partial differential, into the integral, and you get that q of xy, right, is equals to the integral of x0 to x of the partial derivative of p with respect to y dx plus r prime of y, and we use this relation over here, and we substitute in for q. So now we get that the integral of dq with respect to the integral of the partial differential of q with respect to x dx plus r prime of y is equals to q of xy. This simplifies, and it's just q evaluated from x to x0, where x0 is just a point. We will define x0 and y0 to be points in the shared domain between the functions p, x, y, and q of x, y. So the x part cancels out, right? And we get that Why does it cancel out? Well, we get this thing evaluates to be q of xy minus q of x0y. The qx in both sides cancel out, so you get that r prime of y minus q of x0y is equals to 0, so you get that r prime of y is equals to this. And then if you want to find ry, you differentiate, or you integrate both sides with respect to y, which is exactly what we did here. Then you use the original equation that we found, and you substitute in that for ry, so you get that f of xy is equals to the integral from x0 to x of p of xy dx plus the integral from y0 to y of q x0y. And it might be a bit tad confusing, but what is happening here is that x0 and y0 is a point in the region R, as I described, which is the domain of, or the shared domain between P and Q. So you can imagine that, let's say this is the domain that we have over here. It's a shared domain and it describes this region. So x0, y0 is a point on that domain. And what we are doing is we're integrating like this. And this integration basically holds if the rectangle that basically connects between these points, which is x0, y0, xy0, xy, and x0y, is inside that region. So this integral only works if the rectangle that we have over here and all of its line segments and points are inside this connected region over here, or the domain of the two functions, the shared domain of the two functions. And we can basically prove or make sure that this equation over here suffices or works with two formulas that we have, that the partial of f with respect to x is equals to p and the partial of f with respect to y is equals to q. So if you take the partial with respect to x of this thing, well, this is in terms of y, so this whole thing goes to 0, right? And then you can describe again that the partial with respect to x of this integral will just be equals to p of xy, because if you define the integral of p of x y dx to be a function, and then you say that that function, which is g, you substitute in x, so g of x minus g of x minus 0, which is a constant. If you differentiate both sides with respect to x, then the constant part where you substitute in a constant will just go to 0, and you remain with g prime of x, which will just be defined to be p of xy. And then the proof for the q part, or the differential of f with respect to y is equals to q, is a little bit more, has a little bit more length to it. Basically, you have to prove that the partial with respect to y of the integral from x0 to x of p of x y dx is equals to the integral of x0 x. You can, as we have stated before, we can use a basically property that we can get in this thing inside, and we prove that is equals to the partial of q with respect to x dx, and then this just simply is equals to that. So then you substitute that in. We know that this one will simply just be q of x0 y, and then they cancel out, and you get that it is just equals to q of xy. Yeah, that's it.